Hello, in this video we are talking about polygons and reviewing some vocabulary. So first of all, let's make sure we understand what a polygon is. So I'm going to sort these. A star would be considered a polygon, but this oval orb shape would not be. This spiral would not be. This, I don't know what that looks like. Looks like a time thing. Arrow, that would be a polygon. This X would be a polygon. Square would be a polygon. I can't grab it. And then the word bubble would not be a polygon. So let's look at why these are the yeses and these are the nos. So this is basically what a polygon is and the words in the middle. And then on the left-hand side, I have examples of what we mean by that. And on the right, there are counter examples. Okay, what I mean that it shouldn't have. Okay, so a polygon is a closed figure. And what I mean by a closed figure is like this triangle is closed, whereas this one is not. It has an opening in it. With three or more, okay, so three or more, we're talking about sides. So a square has three or more sides, whereas this one over here on the right only has two. That's not a polygon. And the sides have to be coplanar. So this pentagon, all the sides are coplanar, whereas here you could see this has 6 segments for sides, but 3 of them are on this plane and the other 3 are on this plane. So that's not a polygon. And they have to be segments. So make sure that you don't have any kind of curved portion in your shape because that would make it not a polygon. Having said that, 2 sides with a common endpoints are non-collinear in a polygon. So 2 sides with a common endpoint are non-collinear. So this would not be, even though this looks like a triangle, they're trying to say that D is a vertex of that polygon, and that would not be because they're trying to say AD and DC are 2 different sides, and that's not what we consider a side because that's a collinear. These 2 sides would be collinear. So if I didn't have that D there and I just had A, B, C, then that would be okay. But because D is trying to be a vertex, then that's not okay. And each side intersects exactly 2 sides. So when I have each side, it should only touch 2 other sides. So for example, when I have this side right here, that's a counter example, this side is touching the top, the bottom, and it's intersecting this side right here. So that's not a polygon. Okay, and it only intersects at the end points. So in this counter example, this triangle, this side is extended, so that would not be considered a polygon. We would need to get rid of that extension because it would need to end right here. So all of that, if you need to go back and write that down, that's fine. But all of that is what makes up a polygon. So make sure you understand that each endpoint of a side is called a vertex. The plural vertex is vertices. And the way we name a polygon, remember we've been talking about naming objects in geometry. All you do is list the vertices in consecutive order. So if you wanted to start with A, then you could go A, B, C, D, E. You could start with any letter. You start with C and then do C, D, E, A, B, or go around the other way. But you have to list them in consecutive order so people know how to list the vertices. Okay. Parts of a polygon, the sides, which we've been talking about. The sides of the polygon are the line segments. And then the vertices, the vertex, is the endpoint of a segment. So this is a side, right? And then these 2 would be vertices. Vertex, that's a vertex. So make sure when I use those words that you know exactly what I'm talking about. Now we can classify polygons, and this, again, will probably look familiar to you. One way we can do that is by the number of sides that it has. So we know that a 3-sided polygon is a triangle. A 4-sided is a quadrilateral. Now keep in mind, you're probably used to squares and rectangles and all that, but not all 4-sided polygons are rectangles and squares. So don't be specific unless it actually is a square or a rectangle. 5 sides is a pentagon, like the Pentagon building in DC. 6 is a hexagon. Think of a hex, if you think of a hex head bolt. I don't know if you've seen those bolts before. And then 7 is a heptagon. 8 is an octagon, of course, like a stop sign. Nonagon. And then decagon. Beyond that, all we do is just start listing them by their side. So if it was an 11-sided figure, we would call it an 11gon. Or if it was like a 23gon. Okay, so not as nice and, it doesn't flow off the tongue. But beyond that, that's what you call them. So yeah, so there's a generic version of what I was just saying. An n-gon is a polygon with n sides. N can be whatever number you want. Another way we can classify them is by measures. So we can call it equilateral, and that's if all of the sides are congruent. Right? So equilateral means sides are congruent. They're all the same size. They all measure the same length. Equiangular means that all of its angles in the interior are congruent. What I mean by interior, I'm talking about these angles in here, not these angles out here. So we're not talking about that. We're talking about the green ones. All right, regular means that all of its sides and angles are congruent. Sides and angles. So if it's equilateral and equiangular, then we mean regular. We will see lots of things with regular polygons, so make sure you understand what I mean by regular. Another way we can classify polygons is by saying that they are convex or concave. So I'm going to use a house, the shape of a house. Like when you used to draw them back when you were younger. So that's a house. So this would be a convex polygon. And the technical definition is if I draw a line through any of the sides, that line does not pass through the interior. So it doesn't go inside the house at all. Okay, so none of those lines go inside the house. However, if I'm concave, if the polygon is concave, let's say that the roof caved in and it looks like this. So now it's like that. So the problem is our technical definition, if I draw a line that contains this side, do you see that green line goes through the inside of the house? So that means it's concave. So think of like a roof caving in, that means concave. Convex, the roof is pointing out, we're good to go. Okay, so that's another way of naming polygons or classifying them. So let's go through these. Tell whether the figure is a polygon first, and then whether it's convex or concave. So this one, we can't have this, right? That makes it not a polygon. This one's a polygon, and you can see if I draw that, none of it's going through the interior, so this is convex. This is a polygon, but you see how if I do that side, that goes through the middle, so that's concave. This kind of looks like home base, but it looks like an upside down house, so you should probably recognize that that's a polygon that is convex. And this one has this curved side, so that's not a polygon. If you have questions about that, ask me in class. So let's look at these. So classify this polygon by the measurements. Is it equilateral, equiangular, or regular? Well, you see all of the sides are marked congruent, and then all of the angles are marked congruent, so that would make it regular. That would be the most specific. You could actually put all three, since regular incorporates equilateral and equiangular. All right, and then this one, the head of a bolt is shaped like a regular hexagon. That's what I was just talking about. The expressions show the side length. So we're just gonna find the length of a hexagon. Now it says it's regular. That would mean that all the sides are the same. So we know that 4x plus 3 would have to be equal to 5x minus 1. So let's solve. I'm going to subtract the 4x and then add the 1. So x equals 4. Is that what they wanted? No. They wanted the length of the side. So I would be sure to plug this back into here. So 5 times 4 minus 1 would equal 19 millimeters. Here we're going to classify the polygon by the number of sides and then tell whether the polygon is equilateral, equiangular, or regular. So this has 4 sides, which makes it a quadrilateral. Now they have 2 sides marked congruent, but the other 2 are not, so that's not equilateral. We have 2 angles, and these 2 angles are marked congruent, but they're not all congruent to each other, so that's not equiangular. So that it's neither of those. It's not equilateral, equiangular, or regular. Okay, so then in example 4, we have 4x plus 8 and 5x minus 5 represent measures of 2 of the congruent angles in this example 3. Find the measure of one of the angles. Okay, so they're talking about these angles right here. So if they are congruent, then we know they're equal to one another. So again, it's just like the previous example. Solve for, I'm going to move that 4x to the other side. Add the 5, so I'm getting x is 13, but make sure that you find the measure of an angle. So I'm going to plug 13 into here. 4 times 13 plus 8, let's see, that's 40 plus 12, so that's 52 plus 8, which is 60 degrees. So those would be 60-degree angles. So in the next video, we'll talk about perimeter and area.